Good afternoon, ladies and gentlemen. Welcome back, Algebra 1 students. Today we will be talking about solving a system of linear equations by elimination. Now, I know that a lot of you have a lot of questions regarding my absence, and I will get back to you all on Schoology, so please wait patiently. Now, in regards to this video, I do want to jump right into it just because this video will get long if, I go into detail with a lot of things. What you are going to be learning is this process, which is solving a system of linear equations by elimination, right? So the name of the game is to eliminate. We want to eliminate certain variables when dealing with a system of linear equations. So let me go ahead and remind you what that is, right, with the vocabulary. So system of linear equations is a linear equation of two variables, and the two variables do have to match the second equation, right? Now, you can have an example where it's x and y, and here you just have x. That's technically a system of linear equation, but the problem would come up if you have x and y, but here in the bottom you have x and t, right? That is not going to be a system of linear equations because now you have changed equation 2. But this is in fact a system of linear equations, so let's learn how to solve this. So in the previous lesson you learned how to do substitution. Today you're going to eliminate. Now how does this work? Well, Step one of the process says to multiply, if necessary, one or both equations by a constant, right? Constants are examples 1, 2, 3, 4, -1, -2, -3, right? Anything that you can think about. So at least one of the pair of like terms has the same or opposite coefficient. So let's talk about that. Here, what are coefficients? Coefficients are the numbers in front of the variable. So the coefficient of this y is -2. The coefficient of this y is +2. What's the coefficient of this x? Was 3, same as the one in the bottom, right, for equation 2. So now that they are, well, we don't have to do anything about step 1 because they're already opposites, right? Now step 2 says add or subtract the equations to eliminate one of the variables. So now just to make it simple for you, I'm not going to make you consider subtracting, right? So we're just going to make sure that every single time we find two matching variables and the coefficients are opposites of each other, right? So here it's already opposites of each other. So we're going to add these two equations, equation 1 and equation 2, straight down. This is something that you have to be very specific and very careful with how you do things, right? The equality is going to be right on top of each other. The constants right on top of each other. Variables are going to be right on top of each other, right? So you have to be very specific with how you do these things. So you're going to add. So let's see what happens. If we add 3x plus 3x, what do we get? Well, we get 6x. If we add positive 2y and negative 2y, well, what happens there? Well, this cancels out, right? That was the point. To eliminate, right? We're solving a system of linear equations by elimination. Now the constants, 4 minus 4, what happens if we add those things up? Well, we get 0, right? So let's see the next step, which is step 3, solve the resulting equation. So we actually got a new equation from that. Can you see? 6x equals 0. So from this equation, we're going to solve for x, just exactly what step 3 told us to do. And you know in your head, you can do some mental math that 6 times some number equals 0. Well, that some number has to be 0, right? So for those of you who are into mental math, step 4 is substitute the value from step 3, the previous step, into one of the original equations. So you can either plug in x equals 0 into the first equation or x equals 0 into the second equation, and they should both work. So it seems like what the problem decided to do is that they decided to use equation number 1, and they plug in x equals 0. Well, 3 times 0 equals 0. So at the end, you end up getting 2y equals 4. Now, you're supposed to solve for y. How do we get rid of the 2? So here we are multiplying. The opposite of multiplying is dividing. So we are going to divide by 2 to both sides, and we get that y equals 2. So now that we have our x and we have our y values, now we have an ordered pair. Remember that an ordered pair is the solution to a system of linear equations. So the solution is 0, 2. And of course, you can check your work by plugging the x and the y value back in. Now, I want to go on to an example where that is not the case, where you don't have such a perfect world where one of the variables already has opposite coefficients, right? So one of the examples that you see here, look, you have -10 as a coefficient of x of the first equation, and you have -5. Here, the coefficients are not the same, and you cannot just straight up add them. Here again, the coefficient in front of y for this one is 3, and the coefficient for this y is a -6. So you cannot add them up. So that is an issue right here. You have to multiply either equation 1, you have to multiply by 2. And now why does that work? Because if you multiply the entire equation by 2, what happens to the coefficient in front of the y? We get 6. And 6 is the opposite of -6. Now, what the solution actually wants you to do, because of course they're a little bit complicated, they actually want you to revise equation 2. So you're actually going to change equation 2 by multiplying it by -2. Now, why is -2 the constant that we need to multiply? Well, the reason why is because they want to eliminate the x's. How do they eliminate the x's? Well, if we multiply by -2 here, first of all, a negative times a negative becomes a positive. And 2 times 5 equals 10, so we're going to have -10 and +10 as our coefficients in front of x, and therefore they are now opposites. So these are the equations that we started off with, but if we change the second one by multiplying by -2, we get, again, +10. But here, what do we get? -6 times -2. Negative times negative makes a positive. 2 times 6 is 12. Now, -2 times 23. Well, we're doubling 23. We know that if we double 23, we get 46, and we just have one negative, so we get -46. Now we are allowed to go ahead and add the equations up, and we already knew that the x's were going to eliminate because that's what we decided to do. We decided to make these coefficients opposites of each other. So they do eliminate. As you can see here, you get 0. But for the y's, you actually get 3y plus 12y, which is a total of 15y. Now, 1 minus 46, for those of you who like to do mental math, you can also do -46 plus 1, right? That's just the same thing as 1 minus 46, and you actually get -45. Now, from here, you want to solve for y by here you're multiplying in this equation. 15 times y, the opposite of multiplying is dividing, so you're actually going to divide by 15. So y equals -45 divided by 15. Now, for those of you who know, there was 45 divided by 15 is 3, and you are left with a negative, so you get that y equals -3. Now, they decided to substitute -3 back into the equation 2. Again, it also works if you substitute y into equation 1. You have a choice, and that choice will always make sense, right? So you substitute -3 back into equation 2. You replace the y with -3. Negative times negative becomes a positive, so you get positive 18. Now you get this new equation, right? So you get the following. Now you have to combine like terms. You cannot combine the -5x and the 18 because they're not like terms, right? Because this has a variable. But you can combine the positive 18 and the 23. Now notice they are not on the same side. These are some of the problems that some of my students used to face, right? Where if they're on the same side, do you just add them straight up together, or if they're on opposite sides of the equality sign, do you do the opposite? And that is exactly what you got to do in this case. So because they are on the opposite sides of the equality sign, you actually have to subtract 18 to both sides. So if you subtract 18 to both sides, 23 minus 18 does give you 5. And notice how they also give you the step-by-step in what to do. So you get -5x equals 5. What number times -5 will give you +5? Well, for those of you who like mental math, yet again, if you have a negative to make a positive, you know that that number has to be negative, right? So you're going to have negative something. Now, you want to keep the 5, so obviously you're going to have -1 as your x value. Again, you're going to write those as an ordered pair where x equals -1 and y equals -3. That is going to be your solution. Now, for homework, what do I want you to do? I want you to do problems 3 all the way down to 18, and I want you to do all the problems. Now I know that some of you are complaining because it does seem like a lot, but the one thing that you need to do as an Algebra 1 student is just see these functions more, right? Work with them, play with them, manipulate them, change them up, right? You have to actively work on functions consistently, right? Let me help you out with the hard one, right? I can straight out see number 10, right? The coefficients, sorry, the variables are not aligned, right? Here we have the x on the first slot, right? But then we have the constants on the second spot, and then we have the y. None of these are aligned. So what you need to do is you actually need to manipulate that, right? You need to use the operations that you know to change them and make them right underneath each other, right? So something I would start off by doing is, well, first of all, line up the equality signs, and maybe, actually not maybe, I would actually do is I would subtract 3x to both sides, but when I subtracted, I need to make sure I write it right underneath the 3x, right? And the y. So previously what we worked with, if you feel comfortable with this, we did work with the x right next to the y. But if you want to be, if you want to challenge yourself, the constants are already lined up. The -30 and the -6 are already lined up. So you can do this. So long as the variables are lined up, you should not have a problem, right? But if the variables are not lined up, then for sure I can guarantee you that problems will arise, right? So just make sure that the variables and the constants are aligned. Again, if you feel comfortable with how the example went, go ahead and move the constant to the other side, right to the right, and move the y back next to the x. You make a choice. So these are going to be a little bit harder because in order to eliminate them, you may need the least common multiple, right? So a lot of you do a little exercise where instead of finding something that they have in common, here you just multiply by 11, and this one you just multiply by 7, and then you just like cancel them out, right? But then you're going to have huge numbers. So if you actually knew that 12 and 8 actually have a least common multiple of 24, then you can actually multiply the top one by 2, and this will give you 24, and you can multiply the entire second equation by -3. Now, keep in mind, notice how I'm talking about opposite numbers. Opposite numbers, Ms. Sandoval, what are you talking about? Well, I'm talking about the coefficients in front of the x values, and they have to be opposites. Notice how I didn't say 24 and 24. I said 24 and -24, right? Because the name of the game is elimination. The point is you want to eliminate at least one variable. Okay, so keep that in mind when you're working with this. So go ahead and get started, 3 through 18, all of them, and you're going to have to do this work on paper. So you're gonna have to take a picture and send it to me on Schoology. Good luck with that, and I'll see you all tomorrow.